Well, welcome. My name is Mr. Murphy, and I'm going to be going over Lesson 1.1 with you today. And in this video, we're going to be looking at key features of functions. And you can see there for our goal for today is to understand and interpret key features of not only just linear, but also quadratic, absolute value functions when given both an equation and a graph. Now, to start us out, let's review some key terms that you need to be familiar with, and that would be domain and range. Now, a domain, the definition of that is it's the set of all the possible inputs for a function, meaning it's what we can put in for the x value of an equation. So we're trying to find all the values that we can put into a function is defined as our domain. Now, the range is defined as the possible outputs for a relation. In other words, it's all the answers we can get. It's all the results we can get when we put numbers in for x. So we have this idea of a function machine, meaning that we can put numbers in our input and it does some kind of operation to it, and then it spits out our answers. That gives you a nice little visual. Another example would be like a snack machine. Okay, when you go up to a snack machine and you type in that D2, you want to get M&Ms, D2 would be like your input. The output is getting the M&Ms as your answer. So every time you put D2, you'd expect to get the same output. And so that would be another example of a function machine. Let's understand some more. Let's look at this first example where we're going to look at the domain and range defined by y equals x squared minus 3. Now, we need to think of it this way. What numbers can we square? Because that's the numbers that we're going to be putting into our domains. We want to think about what numbers can we square. When you think about it, there's really no limits. Okay, we can put anything we want in there and square it. We can square negative numbers, we can square positive numbers, we can square decimals. Any number I can think of, I can square. So all of them, okay, we can square any real number, and any number can be an input for x. Now, when we put a number in for x, we want to figure out what's the smallest possible number we can get after squaring it. Think about that for a second. When putting a number in for x, what's the smallest possible number you can get after squaring it? 0. Okay, there's no number we can get smaller than 0. Because if we put a negative number in, it's going to become positive. So like negative 2 squared is going to become a positive 4. Well, the smallest we can get is squaring 0. So 0 squared will be the smallest number we can get when we square it. So 0 squared is 0, and 0 minus 3 is negative 3. So the smallest our answer could ever be is negative 3, and it's only going to get bigger after that. So what we just found can be confirmed by looking at a graph. So if we look at the graph of x squared minus 3, you'd get a graph that would look like this. And you can see that if we were to like squish this, if we were to take this graph and squish it on the x-axis, you get an arrow going in both directions. And that just signifies that any number on the x-axis would work. And if you were to squish this graph on the y-axis, you would see that the lowest point on the graph would be negative 3. There's no point smaller than negative 3. And then from there, it's going to go up. Now, there's two ways we could represent intervals of numbers like domain and range. One of those is called set builder notation, and the other one is interval notation. Now, set builder notation uses verbal descriptions or an inequality to describe numbers. So, for example, you could describe it like this for the domain, where we use these fancy brackets, and we follow it by the letter x to identify the fact that we're focusing on the domain. Okay, and then we have this vertical line, and that vertical line represents the phrase such that, and then we would follow it with our phrase. We could say, so this would represent the set of all x's such that x is a real number. We could also use inequalities. Okay, so we could say for the range, we could say, again, we start with the fancy brackets. Those fancy brackets are important, the little scribbly type brackets, followed by a y, identifying the fact now that we're looking at the range as the set of y values, such that, and then after it, we're going to describe what y values are we referring to. So we're referring to all the y values greater than or equal to negative 3. And so that's how you'd set it up using set builder notation. Now, interval notation is one I prefer better. Okay, it's a little bit easier, and you're going to see why. Now, there is some little unique rules that we need to be aware of. So let's look at what it represents. So it represents a set of real numbers by the pair of values that are minimum and maximum boundaries. Okay, so we're going to use a pair of numbers. The first number is going to represent your minimum value. Your second number is going to represent your maximum value. And then we're going to use either parentheses or brackets. And we can use them interchangeably. Like we could use a parentheses on one side and a bracket on the other. Here's how you know when to use a parentheses and when to use a bracket. We use a parentheses when the boundary is not included, and a bracket when it is included. We'll look at some more examples to make more sense of that. Now, anytime we have where it keeps going, we're going to use infinity. We'll always have a parentheses. Okay, so anytime we have, like in the previous example, any number from negative infinity to positive infinity, anytime we refer to negative infinity or positive infinity, we're always going to have a parentheses. So for this example that we were just looking at, we would have our domain being from negative infinity to infinity. In their range, -3 was included. Okay, -3 was a point on the graph. So -3 is included. So it's part of the range. So we're going to use a bracket there. If we used a parentheses at -3, it means that it starts at -3, but -3 wouldn't be included, which sometimes happens, and we'll see when that happens throughout this chapter. But -3 is included, so we'd use a bracket at -3, but then it goes infinitely up. So then we're going to end it with infinity and with parentheses there. So that's what interval notation looks like. So you can compare the two for set builder and interval notation, and you'll see why I prefer interval notation. It's just a little bit more cleaner and a lot easier to write. So here's some other examples of interval notation and set builder notation on the left and on the right there. You don't have to worry about writing all this down. This just gives you a visual of a bunch of different possible ways that we could write it. So let's just look at that first one there. So that first one, having the bracket at 3 and a bracket at 4, means that it's everything between from 3 to 4, and 3 and 4 is included. Okay, having parentheses at 3 and a bracket at 4 would mean that 3 is not included, but 4 is, but it's everything in between there. And then you can see the inequalities on the right there. So look that over. If you need to pause the video to get a better look at it, go ahead and do that. All right, let's look at another example. Here it says an air tanker flies over forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in X seconds? So here we're given that the tank capacity is 8,000 gallons and that it releases at a rate of 400 gallons per second. All right, so let's look at this one. So here's what we know. We know the tank capacity is 8,000 gallons. We know that the release rate was 400 gallons per second. And we know that we're going to use time as our variable. And we're going to represent that with X using time in seconds. And we're trying to find out the function which is going to represent the volume. So function for the volume release after X seconds has gone by. We could set this up as an equation saying that f of X equals 400X. Okay. So that would be our equation. Okay, 400X. So we're not going to use the tank capacity, the 8,000 gallons is not going to be used until we get to finding the domain and range. Okay. So the smallest X can be would be 0 seconds. Okay, so remember X represents the time. So if we have our equation 400 times X, so 400 times the number of seconds, so 400 gallons per second, if X were 0, 400 times 0 would be 0. So the smallest number our domain can be is 0. Now to find the most X can be, we're going to have to do a little bit of work. And this is where the 8,000 comes in. Because we're trying to figure out what would be the longest time it would take for us to dump all 8,000 gallons. So 8,000 would equal 400X. And so if I divide both sides by 400, we would get X equals 20. So what that means is that the shortest amount of time that X could be would be 0 seconds, and the longest would be 20 seconds. Okay, because that's how long it would take to release all of the water. So our domain would go from 0 to 20. And so 0 and 20 would be included. So using interval notation, we would use brackets. Okay, so that's how you'd find the domain. Now let's look at the range. So the minimum amount the tank can hold is 0 gallons of the water. The maximum it can contain is 8,000 gallons. So the range would simply be from 0 to 8,000 gallons. Okay, and 0 and 8,000 would be included, so we would use brackets there if we were doing an interval notation. Okay, here's what I want you to do. I want you to find the domain and range of these two graphs that are given to us here. Now I want you to pause this video, so it'll give you some time to try it on your own, and then once you have your answers, go ahead and hit play to make sure that, and then that's when we'll go over the answer. So go ahead and pause the video now, hit play when you're ready to check your answer. All right, let's check to see how you did. So for the first one, you should have gotten, if you were to put this in, it says to use write both interval notation and set builder notation. So set builder notation, we're going to say the domain is your set of x's. So we have the fancy bracket followed by the x with the such that sign, so that vertical line meaning such that x is a real number. Or you can say x is any number, or x is from negative infinity to positive infinity. I would accept any of those phrases. Basically, you're just describing it in words. Or in interval notation, we would just have parentheses with negative infinity to infinity. So that would be your domain. Your range in set builder notation, again, you have to identify the range being the set of y values. So we'd start with the fancy brackets followed by the y, and then your such that sign. And then it's everything greater than or equal to 0. Okay, so that's in set builder notation. In interval notation, we would have a bracket at 0 saying that it starts at 0. 0 is included, followed by infinity because it's going infinitely up. Okay, the other graph, let's look at that one. So that one, again, the domain for that is going to be the same as the previous one, both in interval notation and set builder notation. The range for this one, though, is a little different. So the range is all the values less than 5 or less than 4.5. It looks like there. So it'd be y is less than or equal to negative 4, or less than or equal to 4.5. Or if you're going to do it in set builder notation, this is where it gets tricky. In set builder notation, remember, you always start with the minimum value, follow it with the maximum value. There is no minimum value here. It keeps going down infinitely. So we say it's coming up, I like to say it like this. It's coming up from negative infinity, and it's going up to 4.5. So go from negative infinity to 4.5. It's very important to have the order correct. If you said 4.5, comma, negative infinity, that is wrong. So make sure that you fix that mistake and learn from that mistake and don't repeat it. All right, so let's review what we just talked, review x and y intercepts. This is something that you should be familiar with. Remember the x-intercept, that's the x-coordinate of a point where a graph intersects the x-axis. It is a coordinate where the y value is always 0. So the x-intercept, like you could have x-intercept of 3. That means it's got the coordinate 3, 0. It's important. Therefore, x-intercepts are also the zeros of a function. Okay, so if they ever ask you for the zeros of a function, they're asking for the x-intercept. Now the y-intercept. A y-intercept is the y-coordinate of a point where a graph intersects the y-axis. And this is always where the x-coordinate is always going to be 0. Okay, so the x-coordinate is always going to be 0 for the y-intercept. And here's a visual for us. So we can see here that this graph, you'd have an x-intercept here at the coordinate 2, 0, or you'd have an x-intercept at 2. And you'd have a y-intercept down here. The y-intercept would be at 0, negative 4. So that's a review of x and y intercepts. Okay, let's look at this example. It says a car starts a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas y left in the tank to the number of miles a car has traveled, x. What are the x and y intercepts of the graph of this equation, and what do they represent about the situation? All right, so if we were to graph this, the y-intercept is 16, and it's got a slope of negative 0.05x. So here's what we know. We know that the x-intercept down there on the x-axis is going to be the coordinate 320 and 0. So that means that it's going to be, the car can travel 320 miles on one tank of gas. That's what the x-intercept represents. The y-intercept is going to be the coordinate 0, 16. And what that represents is the car starts the trip with 16 gallons of gas. And by the time it travels 320 miles, it's going to be out of gas. Okay, so that's how we can interpret the graph. Now, sometimes we're going to be asked to find the x and y intercepts, and we're not going to be able to use a graph. So let's look at how we can do that and think about it logically with what we know about the x and y intercepts. So let's look at this one here. So this one here, it says we're going to, without finding the graph of y equals absolute value of x minus 3, we want to find the x and y intercepts. So let's start by finding the x-intercept. Now, remember what we know about the x-intercept. The x-intercept is always where y is 0. So I'm going to put 0 in for y, and I'm just going to solve this inequality. So I'm going to do that by adding 3 to both sides. So again, for the x-intercept, the y-coordinate is always 0. So I'm going to add 3 to both sides. And now here's what I got to think about. The absolute value of both 3 and negative 3 would be 3. So there's two solutions. There's two things that I could put in for x that would give me 3 as my answer. 3, because the absolute value of 3 is 3, and negative 3. So I have two answers here for x. And the way that you could write that is this is a plus or minus symbol, meaning that your answers are, there's two of them, a positive 3 and a negative 3. So we have two x-intercepts. Now let's figure out how to find the y-intercept. Now remember, the y-intercept is where x is 0. So what we're going to do is we're going to put 0 in for x here, and then we're just going to solve this equation. Well, the absolute value of 0 is just 0, so we get y equals negative 3. So we would have just the one y-intercept of negative 3, and we have the two x-intercepts at 3 and negative 3. Okay, I want you to try the same thing now for this one. Very similar concept. So if you think you can do it, try as much of this as you can on your own. If you get the answers, awesome. If you struggle, that's fine. We'll go over this in just a minute. But I want you to pause the video first and then try it on your own. All right, let's see how you did. So let's start with the x-intercept. So to find the x-intercept, again, using x squared minus 4, I'm going to put 0 in for y, and I'm going to solve for x. So to solve for x, I would add 4 to both sides, so I get x squared equals 4, or 4 equals x squared. Now think about it. Now if you just took the square root of 4 and said your answer is 2, you're only half right. Because you got to think, we're squaring a number and getting 4 as an answer. There's two things we could square. 2, but we could also square negative 2. So we have two solutions just like the previous one. Hopefully you got both of those. But I'm guessing you at least got one of those. All right, let's try the y-intercept. The y-intercept's a little easier. Again, using the equation y equals x squared minus 4, we're going to put 0 in for x this time. And when you square 0, you just get 0, so we get our answer of negative 4. So our y-intercept would be negative 4. All right, let's try another example. In this one, we're trying to figure out for what intervals is this graph positive. Okay, so now to figure out where it's positive, it's going to be anywhere above 0. So where it's above the x-axis, where it's above 0, that's where the values are going to be positive. And that happens when x is negative 3, or x is, less than negative 3, and when x is greater than positive 3. That's when the graph is going to be positive. And so we could write that in interval notation, saying from negative infinity to negative 3, it's positive, and from 3 to infinity, the answers are going to be positive. Now, where is it negative? It's going to be negative below the x-axis. It's going to be below the values where x is 0. Okay, so the way we can describe that interval is it starts at negative 3 and it ends at positive 3. Now let's talk about 0 for a second. The function is neither positive nor negative at 0. Okay, so at the x-intercepts, it's just 0. It's not positive, it's not negative. So we would say at negative 3, 0, and at 3, 0, it's neither positive nor negative. Okay, why don't you guys try this one on your own? So again, just like we've done in the previous examples, pause the video, try it on your own, hit play when you're ready to check your answer. All right, let's see how you did. So to figure out where it's positive, it's that section. So that would be from where x is negative 5 on to infinity. So from negative 5 to infinity, x is positive, or the graph is positive. It's negative below the line. So from negative infinity to negative 5, it's negative. All right. So that brings us to the end of that lesson. So hopefully that will answer some of your questions. But in the next video, we're going to be looking at day 2. We're going to be looking at some more features of our different functions.